Hi, I'm David Ellzey. I'm CEO of Torque3, as you can see. And I'm going to do this a little different than a normal pitch.
Hold on one second, David.
I'm sorry, what?
Hold on 1 second.
Okay.
Are you done?
Yeah, I got it.
Gary? Okay. Yep. Okay, go ahead.
Okay, so I want to do this, my presentation is a little bit different given the makeup of this group. I think you guys would enjoy more of a little bit deeper dive, more of a focus on the technology that we're doing on our platform. So I'm going to be skipping over some of the business stuff, the market, the the revenue strategy, things like that, but feel free to ask them in the Q&A if that's interesting to you. So Torque3 is developing a neurorehabilitation solution that we believe will result in significantly better recovery outcomes. And there's really been a wealth of research over the last 30 years that strongly indicated that stroke recovery can be significantly improved through immersive stimulation and robotic assistance. And I like to believe that our system simply leverages this research with uncompromising design and implementation. The Torque3 platform's most important advantage is that we use intense, deeply immersive task-oriented therapy to enhance neuroplasticity. You see, the Torque3 platform is a robotic-assisted simulator where the patient works their entire body along with all of their senses and cognitive abilities during treatment. This experience-dependent multimodal integration engages functional brain regions, including the sensory, association, and motor cortexes. And we accomplish this with a suite of simulation technologies that operate as an integrated system using our proprietary hardware and software. In fact, the entire platform is computer controlled and all the mechanical functions are robotic. Now, in this video, unfortunately, what I can't really show you is how it feels. And beyond what the writer sees and hears, they feel all the subtle G-forces from every turn or change in speed, the bumps and the texture of the ground they feel through their body, the pedaling and the steering. Even the simulated wind smells like a redwood forest here. The feedback from our servomotor robotics is so responsive, you even feel weight and inertia in the simulation. So like when the rider eases off the pedaling or rolls downhill, they're convinced that they're coasting. And all this to say, you don't feel like you're on a stationary bike, but you're really immersed in the real thing. So a little step back. Task-oriented therapy has proven to increase the effectiveness of neurorehabilitation, but patient impairment and real-world limitations can severely limit treatment options. And I'll explain later how we mitigate hemiplegia with robotics. And I think you just saw how at least got a clue of how we can use virtual environments to overcome real-world limitations. But the question is, why do we need such a deeply immersive experience like you saw in the video? Well, research on task-oriented therapy utilizing virtual reality and robotic assistance has shown that tasks that are continually challenging and continually novel, meaningful rewards result in the most successful treatments. Now, we build on this foundation with the Torque3 platform by delivering the illusion of presence and sense of embodiment required to achieve deep immersion. We then use that deep immersion to have patients suspend their disbelief, which allows us to create a perception of risk. Now, this gives us two very important capabilities. First, it adds intensity to the overall experience, which unto itself can improve neuroplasticity. But more importantly, we use the perception of risk to assign urgency and importance to all the actions performed during task-oriented therapy. Now, our other prime advantage is that we'll completely mitigate the effects of hemiplegia and hemiparesis during therapy. I know, bold statement, but hemiplegia and hemiparesis cause undue struggle for the patients and severely limit treatment options available to therapists. And when the totality of possible impairments is considered, it's evident how delivering effective treatment becomes difficult, or in some cases, impossible. A patient's lateral weakness can severely affect mobility and balance, and their entire arm may be contracted due to spasticity. The weak side's feet and hands may be challenging to keep on the equipment, and over time, major muscle groups such as the quads and glutes can atrophy, compounding the lateral weakness in the legs. And it's also common for a patient's knee to rotate outward when their legs bend, making pedaling awkward or impossible. Now, Torque3's advanced robotics will assist impaired patients' accessibility into and out of the platform with a fully articulated seat that extends to the vertical position. The patient merely leans back, buckles the seatbelt, and the powered system reclines them into the exact position in their custom profile. And Unique to our steering blade design, the patient can steer by rotating their shoulder if spasticity, prevents extension of the arm. Each patient will be wearing overboots, which are hard shell devices that are quick fitted over their shoes. Now, these connect directly to the crank, acting as pedals. And likewise, if the patient requirements, they can be fitted with a hand sleeve that locks their hand to the grip. Finally, to control the position of the knee, a support rail can be attached to the overboot in the seat, and the rail can be moved in perfect sync with the leg when pedaling. Now, by interlinking all these controls and regulated by the unimpaired side, the motor system instantly compensates for lateral imbalance between limbs, delivering a smooth experience as if the patient were not impaired. And for those with significant atrophy, the therapist can use the articulated seat to assist the patient's upper leg. The seat panel is adjusted to the leg side, and the power motion is synchronized to the pedal position, so the weight of the weak legs ease during the return stroke. Now, our goal is to simply make the patient feel whole again during therapy. Now, a quick rundown of our other advantages include injury protection against accidental overexertion, integrated pain management using deep immersion, and we're a unified treatment platform that combines the treatment from lower body, upper body, grip, visual recognition, cognitive into a single multimodal session. Our high level of automation supports streamlined operations by enabling a rapid turnaround of patients between sessions, a single therapist to manage multiple patients simultaneously, which is groundbreaking, and automatically producing detailed progression reports. Now, not are we the only solution that offers any of these advantages. We're the first to implement a truly objective progression data system with well over 20 million points of data recorded per session. Now, this data we process through an algorithm to provide a comprehensive comparative analysis. The data is categorized into 5 groups. The profile data is generally patient information, biomechanical measurements. Session data includes treatment and all the settings, biometric sensors in the grips, and seatbelt record heart and pulmonary rates. But what's exciting to me is the suite of sensors in the headset records brain activity, eye movement, motor neuron signals, stress level, and blood pressure. All the robotic sensors record every aspect of applied force, and the game engine will record all the patient's decisions and deviations from nominal. The algorithm then compares the amount of exertion applied and the patient's skill and the performance metrics by evaluating the appropriate data groups. When the session and the patient profile are adjusted, the algorithm will be able to account for variables and provide accurate reports on the sensor motor progress. So I invite everybody here to follow us on WeFunder if you'd like to receive updates on our development progress. We'll be posting a lot of videos there in the next few months. And I just let this video play while I open it up for any questions.
Great job. You finished in less than 9 minutes. Okay. We'll let the video go. And I guess there are some questions already that have been thrown out. Chris, you had a question if you want to jump in.
Hey, Gary, a disclosure. Yuli is an investor in this. That is me.
Okay. Thank you.
And I'm not voting.
So, David, I think you addressed at least one of these. So this will adapt to any specific deficits that the patient has automatically, or is there something that has to be put into the system ahead of time?
And David, just so you know, Chris is a chairman of neurosurgery at
That's great.
University of Penn System.
Great question. Theoretically, it could adapt, but we wouldn't really want it to start out to learn. He would have to learn from you. We just need to know your deficit side. From that point on, it's all dynamic. We prefer biomechanical measurements prior to the first session as well.
And do you have any, you showed some data, do you have any specific studies with regards to any of your products?
We are pre-testing. We've done internal testing, but we haven't done our internal assessment round yet. That is to come after the, that's our next milestone. This is a proof of concept prototype that you're seeing her pedal. Now that we've handled all of what we considered the larger problems that people had never done before, now we're going to go back and start dealing with sort of more mundane mechanical problems and accessibility, things like that. And that'll be the next version of the prototype that we'll be able to then use for internal studies.
So then my last question is probably moot, because you don't really, I was asking, like, what kind of typical treatment regimen would you expect for somebody that, is hemiparesis, let's say?
Yeah, I mean, we can speculate based upon the experts we have on our team. And the belief now is they certainly want to test it is a more rigorous than we're seeing right now. So typically right now, people are sometimes going in twice a week, 3 times a week. We'd like to, double that, and 30-minute sessions.
And then lastly, what's your timeline? And just give like a 30,000 foot view of any sort of projected financials, like unit cost, anything like that.
Our cost of production in small batch will be 35 to 50,000 per unit. Once we start scaling, and this is mass manufacturing down the road, they drop to 25 to 35,000 per unit. And we're looking at getting to market in about, I would say, 18 months from the time we really get some momentum. And this is all basically contingent on funding, obviously.
Okay.
And Gary, I'll ask a question about potential acquirers. Who do you see as acquirers for this? This is an unusual niche.
It has been a strange world on that. So we've had inquiries from anybody from Konica Minolta, which is a very bizarre fit, but they explained it to us. General Dynamics, strange things coming out of woodwork. A more likely would be somebody like Penumbra. I mean, to be fair, I mean, we've had some interesting inquiries, where they're looking at becoming a possible strategic investor once we get a little further along. And with the really stated thing of saying, having an inside view of a possible acquisition. Both General Dynamics and Konica Minolta made those statements, but they want to see it further along. I personally think somebody like Penumbra would be more likely.
Okay. Mikkel has a question.
Yes, I have a question. So, I know the power of VR and the psychology that it basically creates, but do you have any data about patient adoption and how often do they need to use it to get real benefits?
No, we're pre-data right now. Anything I would be telling you would be other people's research, not on our system, but on the research we use to develop our system.
Marianne has a question.
In the beginning, I believe you had said that the person actually using the device could feel the decline or the change in environment or what they're moving in. How is that accomplished? Does the machine actually move?
Okay, so there's a lot going on here in the simulation world. First off, I should disclose that I've been developing deeply immersive experiences for over 17 years. At a previous company I exited, that's what all we did, really. We specialize in very high-end solutions for that. I'll stop sharing here because that's just repeating. But it is a lot of work to get, stop share. It's a lot of work to make that happen. And what it is we're integrating, we're basically stimulating all of your senses as you go through. So a G-force can be done by, if you take a right turn, I can tilt you to the left or slide you or move you. I can send vibrations that are very, very granular to you that you don't even notice as vibrations or movement. Even the pedaling, you can tell the difference between the texture on the ground if you close your eyes rolling across gravel or grass. We haven't done mud yet, but we know how. So we are integrating all of these things in to make it a more comprehensive. We've already got to that. We've crossed the Rubicon on, is it immersive enough? And the answer is yes. So we've dealt that thing. Any improvements past this point are icing. What we're looking for now as the next step is to make it more accessible and provide, to be able to actually have people do treatments on it.
So David, so we're out of time for questions, but I want to add one other question that was thrown in here, which is a good question, is how much have you raised and how much you're looking to raise in this round?
We've raised over 500, and I'm a little wary in a public forum right now because of something that's going to be happening in the future. Of anything that could be construed as advertising. But in private, I'd be happy to disclose what we're looking to raise. I'm just sorry, but it's like we're filing some paperwork soon, and I don't want to be.
And you'll have the opportunity to interface with attendees post-conference on the network if you
Yeah, absolutely. Anybody wants to talk to me, they can. I just, I've been warned about what I can say
That's
in
fine.
a public where I don't know people.
Understood. Thank you. So you.